Okay, so a couple of videos for this lesson. This particular video will deal with the questions that asked us to justify the formulas that we use when we teach students about arithmetic and geometric sequences and series. So for arithmetic sequences, remember arithmetic sequences, you have some first term, and then to get the second term, you take the first term and add some number d, and then to get the third term, you take the first term and you add another d, and then you take the previous term, and then you add another d, and so on. And so what we see is that in general, the first term has no d, the second term has 1d, the third term has 2d, the fourth term has 3d, and so on. So the nth term has n minus 1d. And that's a justification for why that formula holds. So then you have to imagine that you're adding a bunch of these so that the second to last one has an n minus 2d and the last one has an n minus 1d. When we add all the terms together, these add up to a1 plus an, but these also add up to a1 plus an, because you can kick that d over here. And then the third and the third to last, the fourth and the fourth to last, and so on. So there's a bunch of these being added together. How many? Well, since we pair everybody up, how many? Half as many. And that is a justification for the formula. It's a little dicey if the number of terms is odd. Then you have to look at the median as half the sum of the first and the last. But generally speaking, you're okay there. Kids will understand what's going on. You'll understand what's going on. Okay? Geometric series. Geometric sequences. First, so the first term you have some g1, and then you multiply that g1 by r, and then you multiply that g1 by another r, and then you multiply that by another r, and so on. And so in the same way that the first term had no r's and the second term had one r and the third term had two factors of r and the fourth term had three factors of r, the nth term has n minus 1 factors of r. So it is very, very similar to what we did with arithmetic sequences. So then the question here, what did you do with this? What did you do with this last question here? So S sub n is the first term plus, and so on. And then we multiply everybody by r, and I'll just, for convenience sake, put everybody where I want them. So then what happens? Well, if we subtract those two equations, we get 1 minus r s sub n, and then all of these go away, and we're left with g1 minus g1 r to the n. And then when we want S sub n is this over 1 minus r. If we had subtracted the other way, we would have gotten an r to the n minus 1 over an r minus 1, which is just as valid. In fact, when we end up talking about the sum of an infinite geometric sequence, sorry, an infinite geometric series, when we talk about the sum of an infinite geometric series, we look at this. Why? Well, what ends up happening? If an infinite geometric sequence converges, if an infinite geometric series converges, then the absolute value of r is less than 1. The absolute value of r is some fraction that's just less than 1. And so raising that to higher and higher powers drops this term right out. So when we take the limit as n approaches infinity of this, the G1 is fine, the 1 minus r is fine. It's what happens to this part. And because r is a fraction whose absolute value is less than 1, raising it to higher and higher powers brings this green circled part closer and closer to 0, and 1 minus 0, that's just 1, and that's why we take the first term over 1 minus r. Okay, so all of the formulas that we use with teenagers can be justified, and these are the justifications we use with teenagers. I have taught this to teenagers. This is the way we do it with them, and they can follow all of those explanations. So hopefully this is helpful to you, and now you are empowered to go do those challenge problems that are on that same sheet and nail those things, and then click play and watch what the solutions are officially.